Look at the back of your hand. Its color feels permanent. You have probably seen it every day of your life without giving it much thought. Yet the shade of human skin has changed many times across our history. Those changes followed people as they moved through Africa, Asia, Europe, Australia, and the Americas. Every journey placed the body under a different sky. Near the equator, sunlight can be intense throughout the year. Farther north or south, winter brings shorter days and weaker ultraviolet radiation. Mountains, coastlines, forests, clothing, and food all add their own complications. Human skin had to cope with every version of that world. The color comes mainly from a pigment called melanin. Melanin is made inside cells called melanocytes. People with different skin colors generally have similar numbers of these cells. Much of the visible difference comes from how much pigment they produce, which forms they produce, and how that pigment is packaged and distributed through the skin. Melanin absorbs and scatters ultraviolet radiation before too much of it reaches living tissue. That protection became especially valuable after our distant ancestors lost most of their thick body hair. Early hominins were probably covered in far more hair than humans today. As they became active in hot, open environments, sweating helped their bodies release heat. A thick coat would have made that cooling system less effective. Over a very long period, much of the coat disappeared. The skin underneath now faced the sun directly. Strong pigmentation appears to have developed early in the human lineage, under the powerful ultraviolet radiation of tropical Africa. Researchers cannot inspect the skin of a person who lived hundreds of thousands of years ago, but genetics, comparative anatomy, and the global relationship between pigmentation and ultraviolet levels allow scientists to reconstruct much of the story. Dark, eumelanin-rich skin gave that exposed surface valuable protection. Ultraviolet radiation can damage DNA, weaken the skin's protective barrier, and interfere with important molecules in the body. One molecule that has received particular attention is folate, a form of vitamin B9 involved in cell division, sperm production, and early embryonic development. Very low folate levels during pregnancy can raise the risk of serious neural tube defects. Laboratory work shows that ultraviolet radiation can break down folate compounds. Researchers still study exactly how strongly this affected natural selection in early humans, so the details should be presented as a well-supported hypothesis rather than a solved case. For people living beneath strong tropical sunlight, heavy pigmentation offered a reliable layer of defense. Generation followed generation under the same bright sky. Then small groups began moving into new regions. Their descendants crossed dry grasslands, followed coastlines, entered forests, and eventually reached places where winter could hide the sun for much of the day. The human body carried its tropical protection with it. Thousands of kilometers away from the equator, that protection encountered a very different problem. The weak sunlight of northern winters had become precious, and skin was one of the places where that sunlight had to do its work. Nobody knows who took the first step out of Africa. It wasn't an explorer searching for a new continent. It wasn't a tribe setting out to conquer the world. More likely, it felt like any other day. A family followed a herd a little farther than usual. The next generation settled a little farther still. Their children grew up thinking that place had always been home. That's how human history often moves, not in giant leaps, just enough to make the next step possible. Years became centuries. Centuries became thousands of years. People found themselves living in places their ancestors had never seen. The forests were different. The animals were different. Even the seasons had a different rhythm. Winter lingered. Some mornings began with frost covering the ground. By afternoon, the sun was already sinking toward the horizon. For families whose grandparents had lived beneath the bright African sun, this was an entirely different world. The body noticed long before anyone understood why. Every sunny day had become a little more valuable. Human skin does something remarkable whenever sunlight reaches it, without making a sound, without anyone feeling a thing. It begins producing vitamin D. Nobody knew that 20,000 years ago. They simply knew healthy children grew stronger. Strong bones mattered. A child with weak legs struggled to keep up with the group. An adult with fragile bones faced every journey at a disadvantage. For women, healthy bones could make the difference between surviving childbirth and not. Life had no shortcuts. Every season quietly rewarded bodies that could cope with the place they called home. Scientists think this is where skin color began changing in a new direction. Not in one generation, not even in 100. Parents never woke up to children who suddenly looked different. The changes were so small that nobody living at the time could have noticed them. Only thousands of years later does the picture become clear. One discovery surprised even the researchers. In 2018, scientists reconstructed the appearance of a man who lived in Britain around 10,000 years ago. Today we call him Cheddar Man. His DNA suggests he most likely had dark to medium dark skin, dark curly hair and blue eyes. To us, that combination feels unusual. To him, it was simply his face. Cheddar Man reminds us that history rarely follows the neat picture we imagine. The people who first walked across Europe didn't all resemble the Europeans we know today. The story was still unfolding. And then, people began changing something even more important than where they lived. For the first time, they started changing what they ate. For thousands of years, home could be packed up before sunrise. If the animals moved, people followed. If the river dried out, they searched for another one. The world was always changing. So were the people living in it. Then, in different parts of the world, something remarkable happened. A handful of seeds stayed in the ground. Months later, they were still there. Only now they had become food. It wasn't the first time anyone had noticed plants growing. People had watched seasons come and go for countless generations. The difference was simple. This time, they came back. Again. And again. Slowly, camps became villages. Villages became places worth staying in. The house you built this year might still be standing the next. Children grew up knowing every path between the fields. Grandparents could point toward the hills and remember where they used to hunt when they were young. Life settled down. So did dinner. One of the earliest places where we can see this new way of living is Çatalhöyük, in present-day Turkey. Around 9,000 years ago, thousands of people lived there in tightly packed mud brick homes. Archaeologists have uncovered storage bins filled with grain, ovens built into houses, and grinding stones worn smooth after years of preparing flour. Meals no longer depended entirely on what happened to wander past that day. Food could wait inside the house. That was a completely different way of living. It also meant people were eating differently. Wild game still appeared on the table. Fish still mattered. But in many farming communities, grains gradually became the center of daily meals. Bread, porridge, barley, wheat, reliable, filling, easy to store. There was one catch. These foods contained very little vitamin D. For families living in places where winter sunlight was already limited, that mattered more than anyone could have known. The body still needed vitamin D just as much as it always had. Bones were still growing. Children were still learning to walk. Mothers were still bringing new life into the world. Only now, one important source had quietly faded from the menu. Researchers studying ancient DNA believe this is one reason lighter skin became more common in parts of Europe after farming spread. The change wasn't driven by farming alone. Migration, population mixing, and natural selection all worked together over thousands of years. But agriculture appears to have made the advantage of producing vitamin D from limited sunlight even greater. Nobody planting wheat understood any of this. Nobody stood in a field wondering what effect today's harvest might have on their descendants 6,000 years later. They were simply trying to make it through another year. History has a habit of doing that. People solve today's problem, while quietly creating tomorrow's story. By now, people had spread across almost every kind of landscape imaginable. Some lived beneath tropical skies where the sun shone fiercely for most of the year. Others hunted through snowy forests where winter seemed to last forever. Some settled on wind-swept grasslands. Others built their lives along warm coastlines. Each place asked something different of the human body. And over thousands of years, the answers began to look different too. If you compare people from Northern Europe with people from East Asia today, you might notice something they have in common. Many have relatively lighter skin than populations living close to the equator. For a long time, Chinese like Pos and Cookie and Sinikine, scientists assumed the explanation was straightforward. People moved into places with less sunlight. Their skin gradually became lighter. The story, however, turned out to be more interesting. As researchers began studying ancient DNA, they found that European and East Asian populations reached similar skin tones through partly different genetic changes. In other words, nature solved the same challenge more than once. Think about birds. Bats and birds both have wings. They fly through the same sky, yet their wings didn't come from the same ancestor. Each lineage found its own way into the air. Human skin tells a similar story. Different populations faced similar environments. Different mutations appeared by chance. Over many generations, some of those changes helped people living under weaker sunlight. Those changes slowly became more common. Biologists call this convergent evolution. The name sounds technical. The idea is surprisingly simple. Sometimes life arrives at the same destination, using different roads. Skin color also refuses to fit into neat boxes. There isn't one skin color gene. Scientists have identified dozens of genes that influence pigmentation, each contributing a small part to the final result. Some affect how much melanin is produced. Others influence how pigment is transported or distributed through the skin. Together, they create the enormous range of skin colors seen across our species today. That's why skin color changes gradually across geography. Instead of jumping from one shade to another, travel from the equator toward higher latitudes and over many generations. The average pigmentation tends to shift little by little. Nature rarely draws sharp lines. It usually paints with a very soft brush. When we look around the world today, it's easy to imagine that these differences have always existed. Ancient DNA tells a different story. Our ancestors were changing long after they had reached Europe, long after they had reached Asia. And they are still changing today? Evolution never reached a finish line, because there was never supposed to be one.